My name is Holly Johnson, and I investigated the change in muscle activation due to varying hand grip settings and wrist positions using the handheld dynamometer. We identified a gap in the literature looking at change in wrist position effects on active and passive insufficiency with these specific variables, and we decided to use EMG to collect our force data. We decided to do this because increased EMG activity has been correlated with more force being produced in other studies. Our hypothesis was that the standard hand grip and neutral wrist position on the dynamometer will produce greater force than a modified hand grip or maximum wrist flexion or extension. Our study included 8 subjects with an age range of 23 to 36 years of age. They were all students in the DPT 703 lab class with no skin sensitivity. We determined our EMG electrode placement by palpating the activated muscle belly of the dominant arm, and we collected our max peak values for this test by having them squeeze in a neutral position and proper hand grip on the dynamometer as hard as they could, and using these peak values we found our percent MVC. We then tested and collected data in 3 settings and 3 wrist positions: neutral, full flexion, and full extension, and the shortest setting, the longest setting, and the standard setting on the dynamometer. We calculated mean and standard deviation of all the subjects in these various positions and settings, and you can see these in the figure below. The dark blue bar represents the percent standard flexors, the yellow representing the percent standard extensors, and the gray representing the percent standard force means from the standard position. All of these variables were decreased when taken away from the standard position, excluding the short hand grip flexors. This supports our hypothesis, and one reason that the percent standard flexors were greater in the short position is that it could be a concentric contraction which produces greater force than an isometric contraction. Our data followed the classic link tension curve, which just further supports that idea. Clinical relevance of this information is that we should really be testing our patients in that neutral position with standard hand grip of the dynamometer to get true force data so that we can relate back to them. Thank you.